If you are a developer trying to build AI agent systems, one thing slows you down more than anything: the setup. You run into version mismatches, misconfigured YAML files, silent failures in your workflow. In this video, we will eliminate that friction and get you a working CrewAI environment in minutes. Here are the common blockers: using a Python version that isn't compatible, having config files that don't match your code, and never getting a simple demo up and running. We will fix all of them today. Here's what the project architecture looks like for CrewAI. You use the CLI command to create your crew scaffold. There's a config folder that includes agents.yaml and tasks.yaml. Then, in source folder, you will find crew.py and main.py, and optionally a tools directory. We will step through each piece. Under the hood, a CrewAI project works like this. You define agents, you define tasks, and you optionally assign tools for those tasks. The YAML configuration drives the behavior. Then, in your code, you call crew.kickoff and the system runs. We'll build a minimal version of that today. Alright, let's get hands-on. In this section, we will set up a fully working CrewAI environment from scratch step by step. First, let's open our terminal and create a new folder. Let's go into it. And then we will create a new Python virtual environment. This ensures that any dependencies that we install will stay isolated inside the project. Think of the virtual environment as mini Python bubble. Everything stays contained. Let's activate our virtual environment. Now let's install the actual framework. The CrewAI package is the core engine. It handles agents, tasks, and orchestration. Now it is time to create the actual CrewAI project. For that we will use this command. The CrewAI create crew command automatically generates the right project structure for you. It creates all the config files, example scripts, and all the necessary folders, so you'll start with a consistent professional setup. Let's execute it. During the creation of the project, you will be prompted to choose your LLM provider. In this video, we will choose OpenAI. And the model that we're going to use will be the GPT-4o Mini. We're not going to set up our environment API key here, we're going to set it in a different way. And as you can see, our project was successfully created. Your project folder now looks like this. Inside the source my crew folder, we have the crew.py. That's where we wire everything. You also have the config folder. This is where your all YAML configurations live. At runtime, CrewAI reads those YAML files and understands what your agents should do. CrewAI communicates with an LLM provider like OpenAI, so you need an API key. Instead of hard coding secrets in Python, we will use a .env file. Let's open it, and here you should add your OpenAI API key. We have also specified the model that we're going to use. For this demo, GPT-4o Mini is perfect. It's fast, cheap, and pretty capable. When we run the project, CrewAI automatically loads everything from .env. You won't have to manually read environment variables, it just works out of the box. Now let's define the brains of the operation, our agents. Inside of the config folder, you will find some agents.yaml file. Inside you will find some defaults provided by CrewAI. Let's replace them with our own definitions. Each agent is defined in YAML with three parts: a role, a goal, and a backstory. This metadata tells CrewAI how each agent should think and communicate. The topic placeholder will be replaced dynamically at runtime, but we will see that later. In this project, the researcher gathers raw data, the reporter formats it, and together they form a simple two-agent pipeline. The next thing that you will find inside of the config folder are the tasks YAML file. Let's replace the CrewAI default tasks with our own. Tasks are YAML entries that define what the agents actually do. Each task includes a description, which are the instructions, expected output, which are the deliverables, and an agent field that connects it to one of your defined agents. And finally, we add an output file to the reporter's task that tells CrewAI to save the result as a markdown file that we can open later. By separating tasks from code, we make the workflow flexible. We can edit goals and output formats without touching any Python. Now let's bring it all together. Let's open the crew.py file and replace the CrewAI default code with our own. This class links our YAML configs with actual Python logic. Let's break this down. First, we tell CrewAI where to find the config files. That's what agent config and tasks config do. Then we define each agent and task using decorators, which are the decorator agent and the decorator task. These decorators tell CrewAI to register these methods as active components. The names here must match the YAML keys exactly. Finally, in the crew method, we define how the system runs. The researcher executes research task, then the reporter handles the report task. Setting process to sequential ensures that tasks run in order, one after the other. Now let's look at main.py. First we will start by replacing the default code with our own. The main.py is our starting point. This is where we initialize and run the crew. The inputs dictionary provides dynamic values that replace placeholders in YAML. In this case, the topic becomes generative AI. The kickoff method triggers the entire workflow and returns the result. We also print the result.raw at the end so we can inspect the output directly in the terminal. Before we run it, I noticed a small mistake. We forgot to import the load.env method. The load.env method ensures that your OpenAI API key will be loaded correctly in your environment. Now let's execute our crew. Let's open our terminal, and once you are inside your project folder, type this command. Now that it has finished executing, let's check the logs. First, we see that the CrewAI started the researcher agent. The researcher agent gave its output, and that output was passed to the reporter agent. And as you can see, the reporter agent generated the final output. We can now check the summary markdown file that was generated for us. As you can see, it is almost perfect. The agent only included one wrong line. One thing to keep in mind is that every time you change the topic input in main.py, CrewAI rebuilds the flow dynamically. Try setting it to something else like HAI or vector databases. Each run creates a new markdown summary file with different content, fully automated. Let's take a step back. We started from scratch, installed CrewAI and generated a project scaffold. We defined two agents, a researcher and a reporter. We wrote tasks in YAML that describe what they should do. Then we connected everything in crew.py using decorators and executed the pipeline with a single command. The result is a reproducible, configurable multi-agent system that can generate reports, and you can extend this into research pipelines, code writing assistants, document analyzers, and more. You now have a working CrewAI development environment set up in the right way. There's no debugging nightmares and no misconfigured YAMLs. If you enjoyed this video, please subscribe to ByteBuilder and keep building smarter AI systems together.